Hi boys and girls, today we will work on lesson 26. This lesson consists of comparing fractions that are greater than 1, and using your reasoning skills and benchmark fractions, you will be comparing those fractions versus actually breaking each whole into parts. Today it's more about reasoning and doing this in your head. Number 1, directions: plot the following points on the number line without measuring. Again, with reasoning, but without measuring. And let's look at our different fractions that we need to plot. 2 and 7/8, eighths being your unit fraction, 3 and 1/6, sixths being your unit fraction, and 29/12, that improper fraction, twelfths being your unit fraction. So let's begin with 2 and 7/8. Again, eighths would be your equal parts, but we're not going to divide the wholes. We're going to look at how many wholes we have. We have 2 wholes and some extra. So we know that this is going to fall somewhere in between 2 and 3. And if we reason and rationalize, we say that 2 and 8/8 would actually be 2 plus another whole, which gets us here to 3. So 7/8 is only one piece or one part less than 3 wholes. So 2 and 7/8 would be plotted right there. Moving on to 3 and 1/6, what we have is 3 wholes and a little bit more. So this would fall between the 3 and the 4, but it would not fall as far as this one. 3 and 6/6 would actually be 4 wholes. It would be 3 plus the 1, and we are far from that. We are only 3 and 1 piece past 3 wholes. So 3 wholes, 1 piece or 1/6 past 3 wholes gives us 3 and 1/6 when we reason that. Last but not least, we've got 29/12, and this improper fraction you want to break down into a mixed number. So if we know that twelfths is our unit fraction, 12/12 would be 1 whole, and then 24/12 would be 2 wholes, 36/12 would be 3 wholes, and that goes beyond 29. So we cannot go that far. So we want to stop at 2 wholes and know that 29/12 is the same as 2 wholes, and 24 is how many jumps would it take to get from 24 to 29, or 29 minus 24 gives us 5. Therefore, our mixed number becomes 29/12 becomes 2 and 5/12. And to plot 2 and 5/12 on the number line, we know that it is 2 wholes and a little bit past 2 wholes. So it's going to be in between 2 and 3. And it is, if we rationalize what exactly the middle of 2 and 3 is, that would be 2.5, otherwise known as 2 and 6/12. And we are a little bit below 2 and 6/12. We're a little bit less than that. So if you want to go half and then a little bit less, that's where 2 and 5/12 would fall. Part B is asking us to use the number line that we just completed for part A to compare the fractions that you just plotted and compare them whether they are greater than, less than, or equal to. So you have already completed 29/12. That is up here. That is the 2 and 5/12. And you have 2 and 7/8 right here. So you can tell that 2 and 5/12 is what? Than 2 and 7/8. It's less than, otherwise known as 2 and 7/8 is closer to the whole or larger than 2 and 5/12. So 29/12, otherwise known as this fraction, is less than that fraction. And you're going to use the same numbers you've already plotted to answer here. So you can pause and find those fractions and compare those. Part 2 asks you to do the same exact thing, to plot the following 3 points on the number line, again without measuring but with reasoning. So for this, move my paper up here and make sure we are set. So for this part on number 2, they want you to start with 70/9. And then they want you to plot 8 2/4. That's an easy one. And they want you to plot 25/3. So the two problems that you will need to break down really are 1 and 3. Okay, so for this problem, if you start to ask yourself simply, I'm dealing in ninths. 9/9 is 1 whole. 18/9 is 2 wholes. 27/9 is 3 wholes. What I'm doing is just 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. And if I go all the way up to 9 times 7, 9 times 7 is 63. That would be 63/9, and that is 7 times. If I do 9 times 8, that gets me 72/9, and that I can see I've gone too far. So I want to stop here at my 7 wholes, and 70/9 is essentially 7 wholes, and 63 is how many jumps away from 70. It is 7 jumps away, so we have 7 7/9. And that fraction right there we know falls between 7 and 8. It's a little bit larger than 7 and 7/9. I know that 7 9/9 would be 8 wholes. I'm only a couple tick marks away from that, so I would plot it about right there, 7 7/9. That's just getting you started for number 2, and you will do the exact same thing for part B. You will compare the 3 fractions that you plot here, and you will reason down here as well. Part C, they have added a part C for you, and it asks you to explain, and we know what that means. You have to use words. Explain with words how you plotted those points in this problem 2A. I'm going to give you a couple of hints. I'm going to ask that you use maybe the word converted. You might want to use mixed number. You may want to use the phrase close to. Close to. You may want to use the phrasing more than or less than. And that is how you are explaining where you're plotting these. All right, let's move on to number 3. That is page 2 of problem set. And if we will meet here for the directions, we are going to compare fractions, and we did this in class before we were out of school. We have done this kind of reasoning out loud in the earlier part of Module 5. We're going to compare 2 fractions that they actually give you. We're going to tell whether they're greater than, less than, or equal to, and you are going to give a brief explanation. You're going to kind of think out loud and explain out loud how you came to know whether the fraction was greater than, less than, or equal to in reference to benchmark fractions. And again, benchmark fractions are those easy peasy fractions where you have 1 whole, 1/2, 1 whole, 3/4, 1/4. The easy fractions, your benchmark fractions, are also like your on a clock, quarter after, 4:30, quarter till, 5 o'clock, 5:15, 5:30, 5:45. Those are easy time numbers. Those are benchmark times. So let's start with 5 1/3 compared to 4 3/4. We know that the first thing you might want to do is compare the holes. We have 5 holes here and 4 holes here. So my rational brain says, well, I have 5 holes and a little bit more. I have 4 holes here and a little bit more, but I know that 5 holes is automatically greater than 4. So what does that tell me? It tells me that this fraction, no matter what it is definitely greater than this fraction because 5 is greater than 4. So that's how I rationalize that, and you can explain it that way. And then for part B, 12/6 compared to 25/12. So if I'm explaining this to myself, I will say, well, I know that 6/6 is 1 whole, 12/6 is 2 wholes, so I know that this fraction is really just 2 wholes. And I move over to this fraction and tell myself, Well, I know 12 twelfths is a whole. I know 24 twelfths is 2 wholes, but I've got a 25 here. So I am going beyond. This fraction is actually 2 wholes plus a little bit more. This fraction is 2 wholes plus a little bit more, so I know that this fraction is greater than this one. And last but not least, let's look at 18 sevenths compared to 17 fifths. So if I'm looking at this in terms of, I have 1 whole here in 7 sevenths, I have 2 wholes here in 14 sevenths, and I know that over here, 5 fifths is 1 whole, 10 fifths gives me 2 wholes, 15 fifths for this one would give me 3 wholes. So I'm already reaching 3 wholes on this fraction, and I never reached 3 wholes on this one. For this fraction, it would take me 21 sevenths to get to 3 wholes, but I'm already at 3 wholes here at 15 fifths, and I even have 2 more to go. So that's why that tells me that 17 fifths is greater than that. And you can explain this to me in numbers or words. Good luck. Go ahead and finish all of part 3.